Try something right now. Reach down and tickle yourself, your ribs, your armpit, the sole of your foot. Go ahead. I'll wait. Nothing. Maybe a faint sensation. Maybe a mild awareness of pressure. But not the thing. Not the uncontrollable, helpless, gasping laughter that happens when someone else does it. Not even close. You have full access to your own body. You know exactly where you're most ticklish. You know the precise pressure, the exact speed, the perfect angle. You should be able to destroy yourself. And yet, nothing. So here's the question. Why does the same touch that makes you collapse when someone else does it feel like almost nothing when you do it yourself? The answer is stranger than you think, and it doesn't end with tickling. In the late 1990s, a neuroscientist named Sarah Jane Blakemore at University College London decided to take this question seriously. Most people treated it as a curiosity, a fun fact, the kind of thing you mention at a party and move on. Blakemore thought it was pointing at something much deeper about how the brain understands itself. She built a robot. The machine could deliver a precise tickling sensation to a volunteer's palm on command. In one version of the experiment, the robot was operated externally. Someone else controlled it. In another version, the volunteer pressed a button themselves to trigger the exact same touch. Same pressure, same motion, same location, everything identical. When the robot was controlled by someone else, volunteers felt it. They laughed, they squirmed, they asked it to stop. When they pressed the button themselves, triggering the identical sensation, it barely registered. Same touch, completely different experience. But here's where Blakemore's experiment got interesting. She introduced a delay. Instead of the robot responding the instant you press the button, it waited. 1/10 of a second, 2/10, half a second. At 1/5 of a second of delay, 200 milliseconds, barely the blink of an eye, the sensation started coming back. The longer the delay, the more ticklish it became. At around half a second, volunteers rated it nearly as intense as being tickled by a stranger. The touch hadn't changed. The pressure was identical. The only thing that changed was time. Which means the question isn't really about touch at all. It's about prediction. Here's what's actually happening inside your skull. At the back of your brain, roughly at the nape of your neck, sits a structure called the cerebellum. You might know it as the region that handles balance and coordination, but it does something else that turns out to be far more important. Every single time you initiate a movement, every time your motor cortex sends the signal, move hand toward ribs, a copy of that command gets sent simultaneously to the cerebellum. Neuroscientists call this an efference copy, a carbon copy of intent delivered before the action even happens. The cerebellum takes that copy and does something remarkable. It generates a precise prediction of exactly what sensory feedback that movement is about to produce, where you'll feel it, how strong it will be, what it will feel like. And then, when the sensation actually arrives, it compares the prediction to reality. If they match, if what you feel is exactly what your brain predicted, the cerebellum sends a signal that cancels the response. The somatosensory cortex, the part of your brain that processes touch, goes quiet. The anterior cingulate cortex, the part that registers pleasure, barely activates. The experience gets deleted, not suppressed, deleted, before you even consciously register it. This is why you can't tickle yourself. The moment you decide to do it, the decision itself destroys the possibility. Your cerebellum has already predicted the sensation and filed the cancellation order. By the time your fingers arrive, the brain has already moved on. But when someone else touches you, the cerebellum has no prediction to match against. The touch arrives from outside the system, unannounced, uncategorized, and the brain, with no cancellation order to execute, feels everything. The tickle isn't about touch. It's about the gap between what your brain expects and what actually happens. Now, let's stop here, because this is where it gets genuinely uncomfortable. What Blakemore discovered wasn't just a quirk about tickling. She had stumbled onto the mechanism your brain uses to know the difference between yourself and the world, between what you're doing and what's being done to you, between your own voice in your head and a voice coming from outside it. The cerebellum's prediction system is, in a very real sense, the engine of selfhood. And here is what happens when that engine breaks. In the same paper where Blakemore established the tickling effect in healthy volunteers, she also tested a different group. Patients diagnosed with schizophrenia who were actively experiencing hallucinations and what psychiatrists call passivity experiences, the terrifying sensation that someone else is controlling your body, that your thoughts are being inserted by an outside force, that your actions aren't your own. These patients could tickle themselves, not partially, not a little. They rated self-generated touch as equally intense, equally ticklish, equally real as touch from another person. The cancellation system wasn't working. The boundary between self and not self had dissolved. Think about that for a moment. The same neural mechanism that prevents you from tickling yourself is the mechanism that tells you which thoughts are yours, which voice in your head is you speaking, and which is a voice you're hearing. When the prediction system fails for touch, it doesn't just make you ticklish, it makes you uncertain about who is doing the touching. It makes your own actions feel like they're being performed by someone else. The inability to tickle yourself isn't a limitation. It's proof that your brain knows where you end and the world begins. And most of us have never once thought about it. It just works. Silently, continuously, every second you're alive. But there's another layer here, one that goes even deeper. In 2016, a neuroscientist named Wolpert Brecht at Humboldt University in Berlin published a study that most people outside of neuroscience never heard about. He had been tickling rats, not casually, systematically, with electrodes monitoring their brain activity in real time. And what he found was that the rats laughed. Not metaphorically. They emitted ultrasonic vocalizations at 50 kilohertz, far above human hearing, that correspond precisely to the sounds they make during joyful play. Inaudible laughter, pouring out of them every time a human hand played with them. But when the rats touched themselves, they didn't laugh. Same suppression, same cancellation, same prediction system at work. Which means this isn't a human thing. The mechanism that prevents self-tickling is so evolutionarily fundamental that it runs in every mammal we've looked at. It predates language, culture, and every human thing we consider distinctly ours by tens of millions of years. Your brain didn't develop the ability to distinguish self from world so you could understand yourself. It developed that ability so you could survive. The touch you didn't predict is the insect on your arm. The sensation that arrives without warning is the one that might kill you. The inability to tickle yourself is older than thought itself. It's the oldest part of knowing you exist. Here's what I can't stop thinking about. There's a state of consciousness where the self-other boundary weakens for everyone. Not just people with schizophrenia. Not just rats in a neuroscience lab. When you're woken directly from REM sleep, pulled out of a dream before your brain has fully switched back to waking mode, you can tickle yourself. Researchers have confirmed this. The prediction system hasn't fully rebooted yet. The boundary hasn't solidified. For a few seconds, you can make yourself laugh. And in lucid dreams, the rare state where you know you're dreaming while still inside the dream, some people report that they can't tell the difference between tickling themselves and being tickled by a dream character. Both feel equally real. Both feel equally external. Because in the dream, the entire world is you and the line has disappeared. Which raises a question that neuroscience doesn't quite know how to answer. If the boundary between self and world is a construction, if it's something your cerebellum builds moment to moment and through prediction and cancellation, then what exactly is the self that exists on the other side of that boundary? Is it real? Or is it just the residue of a very sophisticated prediction system that learned to call itself I? There's a moment every morning that most people don't notice. You wake up. For a fraction of a second, before full consciousness assembles itself, you don't quite know where your body ends. The sheet touching your arm isn't clearly separate from your arm. The pillow under your head doesn't feel like an object outside of you. Everything is blurred. And then the cerebellum comes back online. The predictions start generating. The boundary redraws itself. And you are you again, separate from everything else, living inside the familiar architecture of a self. That moment lasts less than a second. It happens every single day, and almost nobody ever notices it. But for one brief instant each morning, before your brain has finished building the wall, you are closer to understanding what you actually are than you will be for the rest of the day. You are a body that taught itself to know it's a body. A brain that learned to feel its own edges. A system that became so good at predicting itself that it called the prediction consciousness. And the proof of all of that is sitting right there, every time you try to tickle yourself and feel almost nothing. The absence of sensation is the signature of a self.